So in this lecture, we're going to talk about probability mass functions. So if we're given a random variable x, we define a function f of x to be one such that f of x is equal to the probability that our random variable assumes the value x. In this case, f is called a probability mass function. For example, if we take the binomial random variable with n successes and a probability p of success, then our probability mass function f of x is equal to n choose x times p to the x times 1 minus p to the n minus x. Okay. So the expected value, let's go backwards. The expected value of a random variable x with a given probability mass function is e of x is the sum over all possible values of a random variable of f of x times x, of the probability that that value occurs times the value itself. Okay, and mu will equal e to x when here mu is the mean of a random variable. So when x is a random variable just of our data and we take our average of the data, the average and the expected value are the same thing. Okay, the variance is related. Okay, the variance, so if we have a probability mass function, we can define the variance, not the variance value, just the variance of the random variable x as the variance of x is the expected value of x minus mu quantity squared. And so an important formula that relates these, our variance of x is equal to the expected value of x squared minus the mean squared. And here I'm using the mean to simply stand in for the expected value. So we go back to our example of the binomial random variable. In that case, the expected value of x is n times p, and the variance of x is n times p times 1 minus p. And the significance of this, we show in these graphs. This first graph, we have n equal to 15 and p equal to 0.7. This gives us a mean equal to 10.5. Well, if we looked at 10.5 on the graph, that's between 10 and 11 here. And that, notice that 10 and 11 are our two highest probabilities. And the variance gives us some idea of how clustered these are, our values around them. I mean, the smaller the variance is, the more tightly our probability will be clustered around the mean. On this graph over here, where we have n equal 10 and p equal to 0.2, the mean, the expected value is 2.0, right? N times P is 2.0. That gives us our highest probability. And our variance is 1.6, which means our probability is even more tightly clustered around that mean.